decision making, and then like your lean transformation, right? And it can be, you can also mention project management, because we are also learning the project management tools as part of the training program. Then the 7 QC tools, statistical process control. So all the tools, whatever we learn under the course, will definitely give you, very good certain skill. So, but though these are very popular, like if you even you can mention, you have got the Lean Six Sigma skill set. Yes, people know. So, and importantly, the problem solving, data-driven decision making, and then you can mention about the, what do you call, the correlation, regression, whatever you are learning here.
Yes, sir. Very important. Correlation, regression, etc. They are very difficult to acquire. So they must mention.
Yeah, because these will act like keywords. When somebody look for an expert or a professional with knowledge in design of experiments, if you have added that in your profile, design of experiments, automatically your profile will stand up, and then it will appear. So your profile will get quickly shortlisted. So that is the advantage. So make sure you add all these skills, and you can also ask for recommendation, right? And we will give. So first of all, we must get connected to, in order to do all these things happen, we need to follow each other, we need to get connected. So whatever Mr. Vivek Kumar said, yes, that will 100% work. And sometimes, it can even get you a big opportunity also. And I have realized it many times. And last week I have signed an MOU with a big company. They have in fact hired me for a certain task. And this is purely due to my presence in the LinkedIn. That's all, right? So please don't ignore this. This is very important information for your career excellence. Definitely do that. Okay, so thank you, Vivek Kumar sir, for the wonderful insight about how LinkedIn profile can help them in the career. So we'll proceed with our training activities, right? Training program. All of you, are you all ready again to dive into the devotion of Lean and Six Sigma? Yes,
Yes, sir.
right.
Yes, sir. Yes.
So today, up to the tea break, I'm going to teach you two important tools. One is control chart. One is control chart, and another one is gauge R&R. Another one is gauge R&R. Hope all of you know little about gauge R&R. Am I correct? Can I get some response here? All of you, do you know about gauge R&R?
Yes, sir.
What is this R&R? Is it R&R means Ramesh and Rajkumar?
Repeatability and reproducibility.
Repeatability and reproducibility, right? So what is gauge R&R particularly? What is gauge R&R? When I say gauge R&R, R&R means repeatability, reproducibility. When I say gauge R&R, what does it mean? What is the meaning of it? Is it a ratio? Is it a ratio?
P by T
P by T ratio. Then what is P and what is T? Is it P means Prem Kumar? T means Tyagarajan? Is it so? What is P and what is T? Come on. We have discussed all this.
Precision by tolerance.
Precision by tolerance. P stands for precision. Precision error. P stands for precision error. T stands for tolerance. So what is tolerance? What is I could see only Krishnavani madam.
Specification limit.
Because she is a professor, she,
Tolerance is a specification limit, sir. Customer specification.
USL minus LSL. Tolerance is USL minus LSL. What is the upper specification? What is the lower specification? What is the maximum you can deviate? What is the minimum you can deviate? This side. You can go that side, you can come this side. The gap is tolerance. You must make sure all the time you play within this. If you are going beyond this, that's altogether a completely different story. Now customer will tackle you. The business owner need not control beyond spec. Customer know how to tackle you, how to control you, right? You see, you try to go beyond USL, LSL, you will realize how good your customer is to you, right? You will see that. Now coming on to the numerator, precision error, which is repeatability error and reproducibility error, right? So this ratio is called precision error. Precision error means repeatability error plus reproducibility error. Together it is called precision error. And the ratio precision error divided by tolerance, the ratio is called gauge R and R. This gauge R and R should be less than 10%. Less than 10% of your tolerance. Hope this was taught to all of you in the meeting. Is that correct, Mr. I think Narendra? I think he's part of Black Belt. He knows. Yogesh, Jnanadravyam and others.
Yes, sir. Yes. Last class it was, sir.
Yes. Yogesh, is that taught to you? I also expect all the student participants to be very active. Is that covered, Mr. Joseph?
Yes, sir. Yes, sir.
Very good, very good. So that is gauge R and R. We always make sure gauge R and R is less than 10% to make sure our data help us to understand the problem correctly. Our data will help us to visualize the problem. We collect data only to visualize the problem. That visualization will give the correct picture only when data is correct. But trust me, it is difficult to collect data error-free. Always errors will populate, and I am going to demonstrate now. Errors always will populate. So it's important that we learn a technique to control it. That is why we have taught you the tool called gauge R and R. How are you going to use the tool? That is called the technique. I am sure you will develop a good technique to use the tool gauge R and R so that the error is always less than 10%. So it will help us to visualize the problem. At the same time, data will become credible. You can always trust the data and take decision, isn't it? In order to further ensure the credibility, we have one more tool called p-value. Which the student participants here, you will be learning in the afternoon, right? The industry participants, they've learned it already, right? So that is about gauge R and R. When it is less than 10%, yes, the measurement system is good to go. 10 to 30%, conditionally acceptable. But more than 30%, unacceptable. More than 30% unacceptable. So I want to take all of you little more deeper, further deeper into the same tool. And then I want to teach you one more important tool called control chart. Whether the process is under my control or not. Whether my own children are under my control or not. If our children are under our control, we can mold them the way we want. If they are not in a position to listen to you, if they are not under your control, do you think you will still be able to mold them correctly? Difficult. So the first thing you need to achieve is process control. Then only you can think about the process improvement. Many a times, projects fail because of not understanding this sequence. If you can control, you can improve. If you can't even control, definitely you cannot improve, right? So as a teacher, if you want to teach a set of students, the first thing you should be good at is gaining a good control over the class. If you are very poor at gaining the good control over the class, you might deliver a wonderful lecture, but nobody will pay attention. What is the point of you delivering a beautiful lecture and then nobody is listening to you? So that is the reason why we often want you on the video, right? We really wanted to know whether all of you are paying attention towards the speaker or somewhere, right? It's very, very important. You pay attention, which tells us that, yes, you are in good control. If you are in good control, yes, we can help you improve. Similarly, Six Sigma is all about process improvement. How do you know whether your process is ready for improvement? A process is considered ready for improvement if it is in statistical control. You are considered to be ready for new learning only, if you are very attentive and if you always keep a smiling face, then even while attending the lecture, right? So even while attending a class, if you could express a smiling face and show the enthusiasm and energy on the screen, and that means you are ready for a lot of learning. All right. So with these things, I want I want all of you to master these two important tools. One is gauge R and R, Another one is process
Control
control or statistical process control, for which the tool is control chart. Tell me which one you want to learn first. You want to already gauge R&R, you learn to certain extent. Which one you want to take it first? Gauge R&R or control chart?
Gauge R&R.
Gauge R&R, sir.
All right,
Gauge
gauge
R&R.
R&R, right? So gauge R&R works with measurement system. It works with measurement system. Measurement system is a combination of different elements. Very importantly, your measuring equipment. The first element is measuring equipment. So we need a measuring equipment. Hope all of you should have the smartphone. Am I right? All of you have the mobile phone.
Yes.
We'll use this mobile
Yes, sir.
phone as a measuring equipment. And inside the smartphone, there will be a clock. There will be a clock, right? And in that clock, there is a stopwatch. Can all of you figure it out and show me the stopwatch in your mobile phone on the screen? Go to the clock and go to the stopwatch and show me. Clock is the application and there is a stopwatch. I could show you, right? Very good. So, but many people only know, very few are on video and they could show you. I want everybody to be very, very participative. Show me your measuring equipment. Then only you are going to be part of my experiment. Yeah, now I could see. Very good, very good. But still, few others are not participating. All of you, please participate now. And now tell me, what is the minimum reading your stopwatch can give you? What is the minimum signal your stopwatch can respond to?
Milliseconds.
1 second.
Milliseconds?
1 second.
Milliseconds, sir.
Millisecond is a wrong answer. 1 second is also a
1
wrong
second.
answer.
1/100th of a second. 1/100th of a second.
Beautiful. 1/100th of a second. Am I right? Can you notice the last two zeros?
Yes,
The last two zeros can gain a maximum value of 99. Afterwards, it gets rounded to 100, isn't it? So that means a second is divided into 100
100.
parts. Each part of a second is called 1/100th of a second, or you can call it 0.01 second, or you can call it centiseconds, not milliseconds. We should be, very good at using the measuring equipment, and we should have a proper operational definition, and we should have the unit of measurement to be same when we are measuring. When I say it is millisecond and you are saying centisecond and someone is saying seconds, there is no logic and there is no meaning in our reading, right? All of us are working in a project, so this is very important. And this 0.01 second is the minimum signal to which your equipment can respond. This is called the least count. Am I right? This is called least count. Hope all of you are familiar with this. Any vernier caliper, your
Balance.
very good micrometer and all those things will have the least count. The other name of least count is resolution. All of you know the word resolution. The resolution, your eye has got a resolution, isn't it? A person with the age of 25, his eye resolution will be extremely good. A person at the age of 85, it may be very poor, isn't it? Yes or no?
Yes, sir.
So
sir.
Yes, sir.
you need a better resolution or poor resolution,
Better resolution.
so that your data can be more credible. So how do you know your data has been collected using an equipment with a better resolution? That's why we require a tool called NDC. That's why we require a tool called NDC. What is NDC? Number of distinct data categories. Number of distinct data categories. Let us say I will be measuring between 5 mm and 6 mm. I will be measuring between 5 mm and 6 mm. And now your equipment, the measuring equipment you have, it has got only 0.1 mm as the resolution. All of you are with me? 5 mm, 6 mm. We are measuring between. What is the resolution I said? 0.1 mm. Now tell me how many readings are possible between 5 and
10,
6.
10.
This is called NDC. This is called NDC. So NDC is nothing but the number of categories of data after data collection. If you categorize your data into groups, 5.1 is a group, 5.2 is another group, 5.3 is another group, isn't it? So likewise, you can divide your entire data into any one of the 10 groups. I want to improve, the credibility. So one way I can do that is I will go for an equipment with a better resolution. Maybe I'm measuring gold, even 0.1 gram. I'm not happy with it. Please understand. I want to go to a higher level of accuracy. So what I do is I go for an equipment with a resolution of 0.01. Earlier, what was my resolution? 0.1. But now what is my resolution? 0.01. Now between 5 mm and 10 mm, I can have 100 readings. Am I right?
Yes, sir.
If it is gold, I'm measuring grams. So between 5 gram and 6 gram, I can have 100 variants. So NDC goes high, isn't it? NDC and resolution. As the NDC, as the resolution becomes better, your NDC will also become better. All of you understand?
Understood, sir.
Yes, sir.
Very good.
Yes,
So this is one thing. So another thing, coming to the repeatability and reproducibility error. So what is repeatability error? You have discussed already. Can one of you please recollect? We'll go for an activity immediately.
The error within the appraiser.
The error within the appraiser. Error within the appraiser is repeatability error. The error between the appraiser is called reproducibility error. If you work in poor coordination with the other team members, you will become a reason for reproducibility error. If you work, with the poor coordination within yourself, then you are committing repeatability error. You yourself not able to do a work, consistently. First time you are doing in a particular way, second time you are doing in some other way, third time you are doing in, completely third method, and now your data will have a lot of variation. That is called repeatability error. Now, let us understand this repeatability error and reproducibility error in a live environment. I want to know some appraiser, and there are a lot of appraisers here. I could see on the video, Narendra, Yugesh, and Joseph, Raghavendra, and then Sai and Guru. So there are six people here. These 6 people will act as appraiser. These 6 people will act as appraiser. The visible people always get the opportunity, right? Just before in the morning we learned. So now these people are visible. So I would like to work with them. So these people will help me with the data collection, and all remaining people, you have to keep answering the questions which I will be asking in between. So what I am going to do now is I am going to make these 6 people collect data as a project team. All of you are working in a project, same project, and you all should help me by collecting data, right? I need the data.
Right,
probably I will analyze it, and the data is the duration of a process. Data is the duration of a process, because my project is aiming to reduce the cycle time, aiming to reduce the lead time. So I want you to measure the duration of a process. Please understand that time has become a CTQ now, critical to quality characteristic, because the project aim is reducing the cycle time of a process. All of you understand our project now?
Understood.
Very good, right? So now how to measure the time? If you want to measure the time, the starting point and ending point should be known to you. Am I correct or not?
Yes, yes.
Yes, sir.
So all of you should understand the starting point very correctly and the end point very correctly. Then only you know when to switch on your stopwatch, when to switch off your stopwatch. If you understand, poorly, each one of you understand in different, each manner, then what will happen? Your data will get contaminated with a lot of error. Repeatability will happen, reproducibility will happen, precision error will happen, gauge R&R will go above 30%, and you all will make the data useless. So that is the reason why you have learned repeatability error, reproducibility error. So please be very, very careful during the data collection. All of you should start the stopwatch at the same time. All of you should stop the stopwatch at the same time. As the process starts, you should start the stopwatch. As the process ends, you should stop the stopwatch. And now your data can become worthy for analysis. So I need to have a process. I need to have a process. In order to ensure you all have a process, what I will do is, should I sing a song? That may not be good, right? That you may not like. So I will prefer to play a song. I'll prefer to play a song from a movie. The movie which you like. I'll play a song. And all these people are going to measure the duration of the song. Is that instruction clear to all of you?
Yeah, clear.
Yes, sir.
The
Yes, sir.
moment I play a song here, the moment you hear the sound of the song, you start your stopwatch. As the song ends, you stop your stopwatch and give me the reading.
Stopwatch.
This is called, what is this tool called? Operational definition. Am I right? Your instruction should be simple, at the same time very clear. Please tell me, is my instruction simple and very clear to all the 6 members here?
Yes, sir.
Yes,
Yes,
clear.
sir.
Very
Yes,
good.
sir.
So
Yes, sir.
my
Yes, sir.
instruction is now called
Yes, sir.
operational definition. Similarly, you can also create your operational definition. Operational definition is, a statement, a clear and concise statement, which will give the same meaning to all the appraisers. Same meaning to all the appraisers. If it gives different meanings, then it creates ambiguity, and it will, it will make your data contaminate with a lot of error, and your data will become unworthy. So with that note, we are going to do the experiment, and now we are involving a measuring equipment, we are involving an appraiser, we are involving an operational definition, we are involving the product characteristics or the process characteristics we are measuring. We are also, all of us are working in an environment called Zoom. All these elements put together is now called measurement system. All of you understand what is measurement system?
Yes, sir.
The
Yes, sir.
stopwatch
Yes,
is an element. You yourself is an element. The instruction I gave you is an element. The Zoom platform is an element.
Appraiser.
The song
Appraiser.
I am going to play is also an element. The song can also disturb you. Am I right?
Yes, sir.
Yes, sir.
Sometimes what happens, we'll be too focused on the song, and later we realize we forgot to switch on the stopwatch. These are all possible, isn't it? So the most famous hero you like, he is on the screen, and now you forget everything. You are now in another world, isn't it? And that's how error can populate, right? So we are going to do that experiment. Hope all of you are ready. All the appraisers, right? And whoever wanted to participate, you can come on video. I can see your participation, effective participation. Okay, I think now many people, I could see them on the video. All right. Because I said, it is movie song, not your... Yes. So I'm sharing the screen. Oh, already screen is shared. I only have to share the slide. So please confirm, is my screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
You can see the previous experiment conducted, lot of data available. I'm going to remove all these things. So 3 songs I have for you, right? So what is the first song? Kabbalah song, right? Prabhudeva song. The second song, Rowdy Baby.
Not visible, sir.
Oh, really? Not visible?
Not visible,
Sir,
sir.
only song 1, song 2, song 3.
Yes, yes. Can you see now?
Yes,
Yes,
sir.
yes, yes. We can
Yeah,
see.
yeah.
Sir, yes, sir.
So second one is the Rowdy Baby. The third one is Bahubali. All right. So let me collect the names of the appraiser. Overall, will be giving the reading. First, who is good? Can you tell me your name? I can collect some names here.
Rustam Ali, sir.
Okay, we have Rustam Ali. Very good. Then
Joseph Biden, sir.
okay, Joseph will be another appraiser. Then one more appraiser.
Krishnaveni, sir. Krishnaveni.
1 second, I'll come. So Prashant Sat Kumar. Very good. Then Krishnaveni.
Narendra, sir.
Srinivas.
Narendra.
Yogesh.
Then Narendra. Then
Srinivas.
Muhammad Arshad.
I don't see, the students voluntarily giving names, and girls particularly. I couldn't, see them participating. Next, who is next? 3 more people I can take. Who is next?
Srinivas.
Anil Kumar. Muhammad Arshad.
Opili Nivas. Then
Yogesh, sir. Sunil.
Yugesh. Next.
Sunil.
Okay, Sunil. See, always, your name should be there in the list, all of you. Always your name should be there in the list, right? The company conducts a recruitment drive and then put a list in the notice board, your name should be there. Your name will appear only if you make it all the time. Not only, when you want. All right. So now these people are going to measure. Others also you please measure, but you record it in your notebook, right? So now, let me reshare because the sound should also come. Share the sound. Take the screen. All right. So shall we go for it now, all of you?
Yes, sir.
Yes, sir.
So please keep your stopwatch in the reset condition 00. And the moment the song starts playing, you need to switch on. So we start with the first song, 3, 2, 1, and here we go. Recording, yeah. If you want to get an estimate of the reproducibility error, you must first of all measure the variation in this data. How will you measure the variation in this data?
Standard deviation.
Range,
Standard deviation.
always range, standard deviation, variance. The better measure is the inferior one is range. Why I call range as the inferior one? It only looks at the highest and the lowest, that's all. It doesn't look at the other things. It is like an 85-year age-old person looking at your data. He looks only 2 things. He can't see the other things. So use standard deviation or variance, but the most popular one is standard deviation.
Standard deviation.
Song 1, how many readings we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 readings. Am I right?
Yes.
9 reading. Can you take the average of the 9 reading for song 1? Possible?
Yes, sir.
Average of the
sir,
9.
yes, sir.
See here.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Yeah. Here is the 9 reading. Take the average. Take this average. Take this average. Average of song number 1. Average of song number 2. Average of song number 3. If all the 3 average are same, reproducibility error is 0. Why do I go for average? I am minimizing the error. Do you understand? I always take multiple reading only to take average. Am I right or not? Multiple
Yes,
reading. You take only to take average,
Yes,
because
sir.
I
Yes,
know
sir.
when I take average, my error can come down. If all the 3 averages yeah, but see here, but one problem here is I have played 3 different songs. Am I right?
Yes, sir.
I played
Yes,
3
sir.
different songs. So obviously the average will be different. That is acceptable. But look at the song number 2 and 3. Look at the song number 2 and 3. What is the duration of the song? What do you
More
think?
or less same.
The duration of the song is, for 2, I kept it as 60. For 3 also, I kept it as 60. Only thing is you people did not know. Am I right?
Yes, sir.
Yes, sir.
Yes, sir.
So I kept it purposely to measure your reproducibility capacity. Look at the Rustam Ali's first reading, 58.31. What is the actual duration of the song?
60.
60.
He put the value below 60. For the same 60 seconds, when hearing to Bahubali's song, he realized, no, he felt like, it's a longer song. Earlier, he felt it like a shorter song. Now he felt it like a longer song. So he gave a reading of slightly above 60.45. Do you understand?
Yes, sir.
Now,
Yes, sir.
now this is a problem of repeatability. Am I right?
Same
this is a problem of
appraiser.
repeatability. For the same song, same appraiser, same measuring equipment, but different reading. One reading is going below, one reading is going above. Is it resembling a normal distribution property? 50% on the left, 50% on the right? That is why normal distribution is always helpful. Similarly, you can notice the repeatability error with Joseph, Prasad, everyone. Nobody gave two same reading except Narendra. Narendra, gave 60.00 and 60.10. But I still doubt Narendra whether he gave me the actual reading or he wanted to simply, trying to be correct. So everything we can figure out. Narendra, you gave the actual readings only, or is it a cooked up reading?
Yes.
Actual
No,
reading.
sir. Actual reading, sir.
Yeah. We can even test whether the reading, is cooked up or it is actual. Actual means it will always exhibit normality. So with this exercise, all of you are able to understand, the repeatability error and reproducibility error. Have you experienced it now?
Yes, sir.
Yes, sir.
So what is reproducibility
Yes,
error?
sir.
What is reproducibility error? The disagreement between or among the appraisers. What is repeatability error? The disagreement within the appraiser. The disagreement within the appraisers. When you want to study the repeatability, you should not let the appraiser know that he is measuring the same part repeatedly. I have made it that way only for song number 2 and song number 3. Song number 2 and 3 had the same duration, but none of you know it earlier, isn't it? If I would have told you earlier, probably all of you could have tried to give at least same readings. So we don't want our operators or appraisers to be biased. We don't want them to be biased, so don't let them know in advance whether they are measuring the same part or different part. Will you be able to control it properly? All of you, do you have some idea? If I give you the job of doing a gauge R&R study, will you be able to actually conduct a study by not revealing the characteristics well in advance to the appraiser? It is something like same part you are giving 3 times, but every time your appraiser should feel it like a new part. Do you get my point or not?
Yes, sir.
He should not be, he should not know that he is measuring the same part 3 times. Krishnavani madam is a professor. I will give her 3 test papers and expect her to correct. She will correct me the first paper, she will correct me the second paper, she will correct me the third paper. She might give, she might give same mark or she might give different marks. But later, after correction is over, I will reveal the fact that all the 3 test papers are one and same. Now, if you look at the paper, you will be surprised to see 3 different marks. So all the 3 are simply the copy of the first one. Now, if there is a variation, what is the error called? If the test corrector, repeatability error. Why the error happened? I don't know. There could be several factors. But if our data deviates a lot, it will become useless because we are going to draw conclusions, decisions only using data. So that is why you should be able to control the repeatability, control the reproducibility, and make sure it is always within 10% of your allowable region. The allowable region is tolerance. Allowable region is tolerance. And again, always when you are conducting the gauge R&R study, the appraiser selection is important. Now there are 30 people here. How did I select the appraiser? Just by randomly. Over on the video, I took it, isn't it? So in your company, in your project, if there are 30 appraisers, conducting the gauge study with all 30 will be tough for you, will be time consuming, will be costlier. You can go for only 3 or 5, at the maximum 10. Similarly, how many songs I played? How many songs I played?
3, sir.
3 songs. But any gauge R&R study, you must have at least 10 songs, at least 10 parts. At least 10 parts. The lowest one should compulsorily be there, and the highest one should also be there. What is lowest? LSL. What is highest? USL. All of you understand? You select 10 parts, compulsorily including the lowest and the highest. Because the lowest and highest are the most deviated items. Am I right?
Yes, sir. Yes, sir.
And the less deviated item will be in the center. The less deviated item will be at the center. Now see to that, you select 5 units between the center and the lowest. Also see to that, you select remaining 5 units between the center and the highest. What is that I am trying to say here? I am trying to achieve here. I am
Normal
just
distribution.
normality. That's all. I am trying to bring normality in my data. Because who is designing the test? You are designing. You are conducting the study. Others do not know, but you should know all these things. Then only you can cross-verify. If you are testing somebody, you should know the result in advance. Am I right? If you are testing somebody, you should know the result in advance. So how much deviation can happen? How much deviation can happen on the left side? 50%. How much deviation can happen on the right side? 50%. While giving test paper to Krishnaveni madam, I give 10 papers. Out of the 10, 3 test papers are failed papers. Now madam is correcting the papers. Now how many students will pass? How many will pass?
7.
7.
7 are expected to pass because I kept 3 failed students paper. That means all remaining 7 are passed students. If madam passed 7 students and failed 3 students, the correction is perfect. Suppose if if all are getting the pass mark, do you still consider the correction as the perfect? No, it had error of 30%. 3 failed students also passed, right? So whether the measurement system is good or not, in order to test, we should always mix some bad parts along with the good parts. Do you understand what I am telling? You should always mix some bad parts along with the good parts. Otherwise, you will not be able to test how your system is dealing with the good, how your system is dealing with the bad. Good should be classified as good and bad should. Am I right or not? If good is classified as bad, what is the error called? If good is classified as bad, what is the error? You have written the exam very well, but you are failed.
Manufacturer.
Manufacturer risk. You wrote the exam well, but you are failed. That's the manufacturer's risk. Type 1 error.
Type 1 error.
If you classify the bad as good,
Type 2.
that is consumer's risk. Type 2 error. A bad engineer will enter the society. Isn't it? So we are trying to control these errors by making sure the gauge R&R is less than 10%. There is only 10% chance you are giving for the type 1 and type 2 error to happen. Do you understand? By bringing down the gauge R&R to less than 10%, we make sure the type 1 error is limited to 10%. Type 2 error is limited to 10%. If the type 1 error and type 2 error are limited to 10%, heated arguments can be avoided in many of the situations. At least 90% of the time, there won't be any heated arguments. For example, if I fail, a student who wrote the exam very well, he will definitely come to me. Isn't it? He will make a call. Sir, what is this? I wrote the exam well. How can you fail? How can you fail me? Will I get a call or not? Definitely the student will come and meet me. Same way, when you reject a good product as a bad, or when you accept a bad product as a good, definitely Either the manufacturer or the consumer will come and argue with you. All these arguments you can avoid by controlling the gauge R&R. If you bring down the gauge R&R to less than 10%, the chance is only less than 10%. That is also the industry standard. But if you can bring it well below, that's much better. Hope all of you understood the gauge R&R, importance of gauge R&R very well. Am I correct now?
Yes, sir. Yes.
Yes, sir.
Yes,
And
sir.
now I really wanted to reduce it. Because why I wanted to reduce? Because it is more than 30%. Because it is more than 10%. More than 10%, less than 30%. What is the decision? Measurement system is conditionally acceptable.
Conditionally acceptable.
Conditionally accepted.
Yeah. See here. Sigma of the repeatability. Sigma of the repeatability means, let us say I myself have measured a characteristics 100 times. I myself measured a characteristics not 100 times, 10 times. Same characteristics 10 times. But I have produced 10 different readings. That's the repeatability error I have committed. So with the 10 readings, I will calculate a sigma, which is sigma of the repeatability for my readings. So sigma can always be calculated. Please understand, sigma can always be calculated, right? If you know the source of the error, then go to the source, calculate the sigma, source data. Go to the source data, calculate the sigma you get. Similarly, sigma reproducibility. Let us say I collected 10 reading. Sunil collected 10 reading. Joseph collected 10 reading. And Narendra collected 10 reading. All of us measured the same product, multiple times, 10 times. Now I want to know whether, we are in perfect agreement or not. So I will calculate my average. Sunil will calculate his average. Joseph will calculate his average. Narendra will calculate his average. 4 people. Now how many averages I will get? 4 averages. If the 4 averages are same, we are in perfect agreement. We are in perfect agreement. If we work in together, the reproducibility error will be minimum. But if my average is completely different from Sunil and Joseph average is completely different from V2 and Narendra's average is one other thing, then the reproducibility error will grow. If I want to get an estimate of the reproducibility error, I will use 4 appraisers, 4 averages. 4 appraisers, 4 averages. Now, how do I measure the variation? There is only 4 data points. When the number of data point is less than 8, calculate the range. Calculate the range and convert the range to standard deviation. There is a statistical procedure which you will be learning in the control chart. When data points are less, calculate range and convert it into standard deviation. But if data points are more than 8, straight away calculate standard deviation. That is sigma reproducibility. All of you understand? Now sigma
Yes, sir.
repeatability is there, sigma reproducibility is there. Combine them. Combine means square and then add, take the square root. Like your Pythagoras theorem. Square, add, take the square root. Now this is the resulting sigma. Resulting sigma is nothing but estimate of the repeatability and reproducibility error together. And this is only not estimate, this is only standard deviation. In any population, how many standard deviation will be there? On the right side, 3 standard deviation. On the left side, 3 standard
3
deviation. After 3 standard deviation also you have so many standard deviation. But that will only account to a small percentage of the population. We know when we go up to 3 standard deviation on the right as well as on the left, what percentage of the population we are able to understand? 99.73. I expected this number to come from each one of you. So always you multiply your sigma by 6. You are now able to get an estimate. Which is 99.73% accurate. You are able to get 99.73% of the error by multiplying the sigma by 6. That is why we have taught you normal distribution. Now 6 into sigma of the error This is called precision error. See here, numerator. This is called precision error. The denominator, tolerance, USL minus LSL. Now you have the ratio, precision tolerance ratio. What is the name of this ratio?
Gauge R&R.
Very good. So this gauge R&R should be less than 10% to consider your measurement system as good. 10 to 30%, conditionally good. More than 30%, unacceptable. More than 30%, unacceptable. Your data is a garbage. Garbage in, garbage out.
Sir,
Whenever you are, yes,
conditionally acceptable means?
conditionally acceptable means, you see here, you are working between 99.5 and 100.5. What is the center now?
100.
100.
So what is the tolerance? 1 mm.
Point.
When you are working in 1 mm tolerance, what is the gauge R&R rule says? 0.1 mm can be error. 0.1 mm can be error. If you have 0.1 mm error, 90% of the time you are safe. But 10% of the time you are under risk. That risk area is marked here. Can you see the gray area? When you produce here, you will commit type 1 error or type 2 error. When you produce here also. When you produce here, the product is good or bad?
Good.
Bad, because it is out of spec.
Okay.
But because of the equipment error, your quality inspector will bring it here. Possible or not? Error can be plus, error can be minus.
Yes.
I can give you extra 5 marks, I can also reduce 5 marks, right? So error can be plus or minus. So when you produce here, type 2 error will happen. When you produce here, type 1 error will happen. Why these errors are happening? Because you are producing in this manner. Look here, you are producing everywhere. If you are producing everywhere, you must strictly follow the industry standard. Gauge R&R should be less than 10%. For you, the second condition is not applicable. You are not a world-class manufacturer. You are an ordinary manufacturer, ordinary service provider, because you produce occupying all the tolerance. You produce occupying all the tolerance. But you are a matured company. All your people are skilled enough, so they keep on improve the process. If they keep on improve the process, now you are able to produce in this manner. Do you understand where are you producing? Now you are slowly becoming, world class. I will call you a real world class if you produce everything around the center. But now you are close to world class. You are producing, in this manner. Can you see the control limit falling well inside the specification limit? Yes or no?
Yes.
If you can see your control limit falling well inside the specification limit, this 10% error do not have a chance to affect your product. Am I correct or not?
Yes.
Yes,
This 10% error do not have a chance to affect your product because you are not coming into the risky zone at all. This zone is called uncertainty zone. It is like India-Pakistan border. If you go to the border, there is a very, very less chances there you can come back, isn't it? So that's why we always avoid these border areas. It is well protected. Same way, you should also protect your risky zone. If you clearly know your control limits are well inside, then you can consider using your measuring equipment even with a gauge R&R of 10 to 30%. All of you do now understand the meaning of conditionally accepted?
Yes, sir.
Yes, sir.
You can't understand this anywhere outside. If you have understood, yes, you are definitely on top of the experts in the market.
Sir, conditional means it is not, we are not expecting for every product. For according to the company norms, we are expecting for temporary. That we can say.
See, some companies take the advantage of the statement conditionally acceptable. Conditionally acceptable means my project champion is saying, okay, you work. That these are all pure internal. There is no technical logic behind. The technical logic I have explained. Sometimes measuring equipment is too costlier. Do you think your company will immediately replace the measuring equipment?
No.
It is going to cost the company 45 lakhs. They'll say, no, you continue with this. See, those are not the real meaning of conditionally acceptable. Strictly speaking, statistically speaking, when the error is 10 to 30%, and the control limits are well inside, even 30% error should not come and affect your decision.
Yes, that's
Then only it is conditionally acceptable. Only statisticians, pure statistician can understand this definition, right? Otherwise, sometimes, we also tell, okay, if the company cannot afford, okay, accept it, conditionally accept, but that's not the real justification. But in any case, more than 30% unacceptable. Hope it is clear to all of you, right? This is the Minitab report. This is a Minitab report. Look here. How much is the error? 27.37. Conditionally acceptable condition. If you look here, repeatability is this much, reproducibility is this much. Which is more? Repeatability is more or reproducibility is more?
repeatability.
Repeatability is more. Part-to-part variation. What is part-to-part variation? That is the problem you are attacking. That is the problem you want to produce every product around the target, isn't it? But your product is moving away from the target. That is called part-to-part variation. When you want to attack the problem, you should be able to see the problem correctly. You can see better only when the gauge R&R is less than 10%. But here it is 27%, right? And so you should control the error, probably, improve the operational definition, improve the condition of the measuring equipment, train your operators, make all these improvements, gauge R&R will go down. And NDC, I spoke about NDC, do you remember? Number of distinct category. NDC depends on resolution. This is the formula to calculate NDC for continuous data. Standard deviation of the part, it is here, part to part, standard deviation. Standard deviation of the gauge, it is here, gauge is standard deviation, here, gauge R&R. So, you part standard deviation divided by gauge standard deviation, multiplied by 1.41, and that will give you the NDC value. That NDC value should be minimum 5, the more is better. And now, if there is a problem you observe in this report generated by Minitab, Minitab will generate this report in few seconds. But if there is a problem, you want to understand the root of the problem, you should be very good in reading all the graphs. How many graphs you are seeing here?
No doubt, sir. Part-to-part variation is more than 100%, isn't it, sir?
Yeah, correct. It is simply because you are working with the standard deviation. Standard deviation plus also standard deviation minus also standard deviation.
Yes, sir.
Plus also deviation minus also deviation. So that is why, total variation can be more than 100%. If you want to see, if you don't want to, go beyond 100%, then you must work with the variance, not with standard deviation. There are two approaches available. When you work with the standard deviation, this won't tally. You can see repeatability error plus reproducibility error. If you sum up, it is not equal to 27, isn't it? If you want to see 27, you square the 20, square the 18, add them, take the square root, then 27 will come.
Okay. Okay, sir.
So that is the problem with the standard deviation. But we are studying everything with the standard deviation. That is why, I have taken report using standard deviation. You can take report with variance also. There 100% will come here. Total variation will become 100. And if you sum up all these things, that will tally, but not with standard deviation. Now there are 6 graphs. The first graph is called a bar graph. Second graph is a control chart, which you must learn control chart, that is pending. And third graph is also control chart. The second one is R chart, range chart. Third one is X bar chart, which is average chart. The fourth one is called dot plot. You can see several dots in the graph. So we call it dot plot. The fifth one is called box plot. You can see 3 boxes. The sixth one is called interaction plot. If you know how to read the graphs, you will be able to fix all the problem and arrive a solution to bring down the gauge R&R. Now tell me, how many of you are very good in reading the graph? You might have used all these graphs, am I right?
Yes.
Shall we go through the graphs?
Yes,
Shall we go through?
Yes, sir.
First graph,
Sir.
bar graph. Now there are 3 colors: blue color, red color, and
Hello.
yellow color. And the blue is for what you call percentage contribution. When you don't know tolerance, then only you should use blue. What is tolerance? USL, LSL. If you know the tolerance, you must come to either red or yellow. Now red is, yeah. Now there is red as well as yellow. Now there is red as well as yellow. Sorry, let me correct my statement, right? So there are three graphs, blue, red and yellow. Blue is with the variance, red and yellow with the standard deviation. Blue is with variance, red and yellow with standard deviation. So what is that we are working with? Standard deviation. So far as the applicable is red and yellow. And within red and yellow, when USL, LSL are known, you must use yellow. When USL, LSL are known, you must use yellow. If it is not known, you must use red. Look here, the name of the red is study variation. Name of the yellow is tolerance. Use the yellow only when USL, LSL are known. Most of the time you will be knowing the USL, LSL. Am I correct?
Yes, sir.
Yes, sir.
So I remove all the other things. Now you only have yellow. Now you only have yellow. This is the problem you are attacking. These are the issues that is preventing you to see the problem. Repeatability error, reproducibility error. Together, it is this much.
Yes, sir.
Now out of the error, repeatability is little higher than reproducibility. So try to control the repeatability as well as reproducibility. Your gauge R&R will come down. Do you know how to read this first graph?
Yes.
Yes, sir.
Now R chart, range chart. Now there are three operators. Operator 1, 2 and 3. Now tell me, which operator is collecting the data perfectly from your viewpoint according to the graph?
Third one, sir.
3.
3 is good?
Yes, sir.
Okay,
Yes.
3 is good. And how about 1? 1 has lot of variation, right? You can see.
Yes.
But all of them, the variation is under control limit only. But
Yes.
within the 3, you are saying one is the worst within the 3. Though it is acceptable, but 1 is having too much variation. But the 3, 2 less variation. How about the 2?
2 is so close, sir.
2 is also okay, isn't it? But can you look at the reading of 2 here? Perfect straight line.
Yes, sir.
If you see an ECG graph becoming a perfect straight line, what does it mean?
Dead.
Structure is over, right? So which is abnormal? If you see up and down, that is normal distribution. You remember I told you to select 5 parts, left side, 5 part, right side. Am I right? But look at the operator 2. He is placing everything on the upper side only. You still accept him?
Yes, sir.
In my opinion, 2 is more dangerous than number 1. Am I correct or not?
Yes, sir.
Though his readings are too close to the center line, his readings doesn't resemble normality. That means he is biased for some reason. You may have to bring it down. So this is how you need to read, and then make sure your reading also exhibit normality. If your reading also exhibit normality, your reading should go up and down, isn't it? If the readings are going up and down, yes, the person is normal, the health is normal. If it is only giving you the peak, it is abnormal. Doctor's attention is immediately required. If it is a flat line, then the chapter is closed, right? So you have to be very careful with the signals you receive from the control chart. And this is R chart. Now, R chart helps you to control the repeatability error of the appraiser. Am I right? Each single point is a range. Am I right or not? If the range is under control, the repeatability error for the particular appraiser is under control. Am I right or not?
Yes, sir.
For example,
Yes, sir.
operator 1, 4th part, he committed the repeatability error too high. 5th part also he committed high. 10th part also he committed high. And operator 2 also, for part number 2, he committed more repeatability error. Do you understand? Operator wise, part wise, we are able to visualize the repeatability error. How many of you understand? All of you.
Okay, sir. Understand.
Yes, sir.
Now the next chart, X bar chart. This will help you to visualize the reproducibility error as well as it will check the the ability of the measurement system to categorize the good and bad. I told you, when I give you 10 test paper, 7 test paper pass mark, 3 test paper fail mark. Now you are actually correcting the paper. How many test papers should actually pass? 7 should pass, 3 must fail. Now, who selected the parts, 10 parts in your gauge R&R study? The project leader, am I right? Or it is you who is conducting the gauge study. When you select the 10 parts, I told you to purposely mix some bad parts. Am I right or not? Am I correct?
Yes, sir.
If you mix 50% bad and on all remaining good, you should get all those 50% points outside the control limit. If that is not happening, please understand you are passing even a failed candidate. Is it clear to all of you?
Yes, sir.
You mixed the 50% bad parts, so bad parts should appear outside control limit.
That's clear.
If that is not happening, you see 50% of the points are outside. If that is not happening, that shows the inability of your measurement system to categorize between good and bad. Now, what is this? Response, part-wise response. Every single part is measured by each appraiser 3 times. How many appraisers you involved in the study? 3 appraisers, am I right?
3 4
Each-
sir.
3 appraisers or 4? 3 only. You involved 3 appraisers and every appraiser measured every part 3 times.
What is the
So each part will produce 9 reading. Am I right? Can you see 9 readings
Yes, sir.
here getting plotted, and you can see all 9 here. If you can see all 9 points here, what does it mean? Your measurement system is very bad at measuring part number 10. Can you notice? For the simple reason, all these readings came from the same part. It should have been like a pile of coins. You could see your team working well with respect to part number 7 and 6. Can you notice? 6
Yes,
and
sir.
7 are good. 10 is the worst. You can comment on the remaining. Take action, appropriate action. For 10, can one of you tell me what will you do? If you see a point like this, what is your action now, corrective action?
We have to change the operator, or we have to instruct the operator.
This is like Bahubali song. You are getting distracted while seeing the song. So you should be trained on how to measure part number 10. Somehow part number 10 is giving you a lot of problem. You should be trained, little more to measure part number 10. You will see all the points coming close. If all the points come close, the reproducibility will come down. All right. Now, box plot. Box plot will help you to control or understand the reproducibility. If there are 3 appraisers, if my average, your average, and the third person's average all are same, you will see this averages on the perfect horizontal line. Am I right? See, this crossbar is the average. Since the averages are not on the perfect flat line, perfect horizontal line, there is a reproducibility error. Who is pulling down the average?
2, operator 2.
Operator 2. Operator 2 is not aligning with 1 and 3. Operator 2's average is below the average of 1 and 3. Now another question, whether 2 is correct or 1 and 3 is correct.
1 and 3 is correct.
If 2 is correct, 1 and 3 should align with the 2.
Okay.
If 2 is wrong, 2 must align with 1 and 3. This also you can understand by carefully designing your gauge R&R study. If you select the 10 parts in such a way, that mean equal to median. Do you understand one of the property of normal distribution is mean equal to median equal to mode? Am I correct or not?
Yes, sure.
If you select the parts in such a way that mean is equal to median, for example, 5.4, 5.5, 5.6, what is the mean? 5.5. What is the median?
5.5.
So it is in your hand. You can make the mean equal to median. If mean is equal to median, who is correct? Median is nothing but the center line. Please understand. For operator 1, mean is different from median. But for
Second
operator
one is
2,
correct.
2 is correct. So what is your action now? You will try in 1 and 3. You will try in 1 and 3, isn't it? So what happened? 1 and 3 will start aligning with 2. So this is how you can control the reproducibility. And now this is called interaction plot. It is nothing but your third graph. What is the third graph you have seen? What is the third graph you have seen? X bar chart. 3 X bar chart you have. If you overlap all the X bar chart one over the other, you will get something called interaction plot. You will get something called interaction plot. 1, 2, and 3 all are one overlapped with the other. If there is a perfect overlapping, reproducibility is at its best. If there is a perfect overlapping, reproducibility at its best. Now, if it is not overlapping, at least they should be parallel to each other. At least they should be parallel to each other, not overlapping and not parallel. Now, who is responsible? Look at the one who is crossing the line and disturbing the parallelity. There are 3 people, right? Look at the one who is not parallel and who is crossing the other one's line. And that he must be corrected. Do you all understand how to read the graph? Yes or no?
Yes,
See
sir.
here, 4 to 5, all are coming down, isn't it? All are coming down. All are coming down. Right? And 5 to 6, 5 to 6, all are going up. But you can see the green crossing with the blue, isn't it? And red also slightly crossing. So when there is an intersection of these lines, it means there is an interaction. Their behavior is slightly abnormal, becoming abnormal, particularly while measuring the part number 6. Up to 5, all the 3 they behaved properly. That is why they are coming parallel. Now something went wrong. I do not know whether whether the product is difficult to handle or the measuring equipment is difficult to handle. I do not know, but something wrong is happening. That is the reason for interaction, and that is the reason for intersection. And here intersection is so strong by the blue color person. Can you understand? So something like that you need to read, understand the situation. Particularly, you will be able to understand the graph very well if you have designed the study properly. If you have designed the study properly, then you will be able to read it very well. This is how all of you can conduct the gauge R&R study and make your data worthy for analysis. Make your data worthy for analysis, right? And that's it from me. So we will probably discuss on the subject if you have any further questions, or otherwise please, many of you are not utilizing the capitalizing the Wednesday class, Thursday class, and we see poor attendance, we see poor acknowledgement when we are announcing about the extra classes. Please have the habit of acknowledging the informations that are coming to you, because if you acknowledge, probably you will note it down. If you don't even acknowledge, and definitely you will miss the class. So we can discuss more on the gauge R&R probably if we get additional time on Wednesday or Thursday. So I stop here.
Okay, it is recording. Now, in the last class, did I conduct a GEMS experiment? Say yes or no?
No, sir.
Huh?
No, sir.
GEMS experiment I did not conduct. Okay. What I will do is I'll just explain what is DPMO and DPO and all, defects and all. And then from there, what is Z and CPCPK I will teach you. Okay. I'll share my screen. Are you able to see my screen? Yes or no?
No, sir.
Yeah,
no.
sir. Yeah, sir.
But this thing is not working.
Sir, no, sir.
We'll wait for some time. It is stuck there.
Sir, not visible, sir.
Once again, I do not know what happened. Yeah.
Yes, sir.
Because mine was not working. I will close everything so that yeah. Now you are able to see my screen, right? What I will do is VBA is there, VBA. Yeah, VBA Excel documents. And then I will take it as the error bar analysis, DPMO sigma level. Yes. See here. Now, I have got a lot of data here. Now, a GEMS experiment, I'm going to do this. GEMS experiment, what I do is, I'm going to ask people, each GEMS box will have 10 gems, and I'll have to ask for the defects. I'm giving 5 defects opportunities, 5 opportunities for error. That means one is for the count. That means if the box has 10 gems, there is no defect. If it has 1 extra, 11 gems, then the defect is 1. If it has 9 also, defect is 1. Understood my definition of defect? Yes or no?
Yes, sir.
Yes, sir.
And then cracks. How many gems are cracked? How many gems are of different shape? And how many gems of faded color? It can be of different color. It can be faded color. So faded colors are defects. And taste. If it is not tasty, all the 10 gems are defects. If it is tasty, no defect. So I'm going to put Gayatri is the first candidate in the previous one. She said that I have opened one box and now number of sample is 10. How did I get this 10? Number of boxes into items per box. So you understood how I calculate this? Yes or no? Hey, somebody will have to unmute.
Yes, sir. Yes, sir.
Yes or no?
Yes, sir.
Otherwise, I will be wasting time waiting for you. Right? So, and then she found that count is two counts defects. She was having 12 gems and color 1, rest of the thing are there. Okay. Therefore, 3 defects. So defects are put here. Opportunity for error is 5 because crack, count, shape, color, and taste. Right? Therefore, total opportunity for error is 10 into 5, 50, and 3 by 50 is 6 by 100. Defects per opportunity is defects divided by sample into opportunity for error. This is where it is. I'm just calculating and then multiply by million per opportunity 0.06 per million opportunity multiply by million, that is 10 lakhs 60,000. And once I get this 60,000 DPMO, sigma level is calculated. How it is calculated, we will teach you later. It is purely a function of DPMO. Understood? So far clear?
Yes, yes, sir.
Now I'm just, you can give me a
Yes,
Inky Pinky Punky, Prashant Kumar. You just tell me any value you like. So count, is there any defects?
Yes, sir. One.
How many? One defect.
One number.
Right? 11 is there.
Yes, sir.
Color, is there any defect?
Color. No,
Then
sir.
I'll put 2. Crack, is there any defect?
2, sir.
2. You be fast, otherwise I will take shape. Is there any
Okay.
defect? I'll take it as 1.
1.
Taste is no 0. And then one more
Yes.
gentleman, please give me. Count, is there any defects?
Sir, 3.
Okay, I will take it as 2. Color?
1, 3.
Yeah, see, somebody is fast. Please tell me. Crack?
2.
2. And then shape?
1. 2.
1. Taste is 0, I'll put. Right? See, here 3 boxes are open. So it is 30. 30 into 5 is 150 in the denominator, 17 in the numerator. And that is difference per opportunity is 0.113. per million, it is 1,13,000, and sigma level is 1. Please note the difference between the two will always be 1.5. Right? Now I'll just copy it. See here, total defects have to be 69 found out. You can do this calculation later on. All you need to do is check it yourself. Total is tallied here, column wise and row wise. And then sample is 70, 7 into 10 is 70. Opportunity for error is 5. 70 into 5 is 350. 69 by 350 is 0.197143. This template, I'm going to share it with you. You can play it at leisure time in your college with your professor. Probably she can arrange for this game, and then you can test it. What is the sigma level, short term and long term? Please note, what should be the sigma level for a good performance? What is the course name? What is the course you are doing?
Six Sigma.
So what is the best performance?
99.99.
Six Sigma. Six Sigma performance is the best performance. Yes or no?
Yes, sir.
Okay. Okay. Now you are getting sigma level is 0.8, 2.35, very low. You should get sigma is 6. Yes or no? Right?
Sir.
Sigma level 6 sigma we should get. So this is doing well or not doing well?
Yes.
This is doing well or not doing well as per this?
Not.
No.
No.
But Gens is really doing well in the market. Monopoly. Because we have made a mistake here. RK has made a mistake. RK has made 2 mistakes. Number 1, he has not taken the right sample. He should not have discussed this with you. He should have taken children, because it is meant for children. Number 1 defect, number 1 fault. Understood? Yes or no? Number 2
Yes.
fault I made was, RK made was, that all the opportunity for error all not at all relevant for children. What is relevant for children is only taste. Therefore, if I put 0 here everywhere, then it is a very good process. Please see here. And then you can see here. So infinity. Sigma level is very good, right? Even if I put 1 here, it will be 4.26. It is good. Therefore, you will have to do a sample study very carefully. Understood? I'll stop sharing here. Now I have taught you what is defects. What is defective means if all the defects are not, if all the specifications are not met, then it is called defective and it is to be rejected. A defective is to be rejected. A defect item may not be rejected. Understood?
Yes, sir.
All this. Now I will take you to how to calculate this defects, defectives, and then CP/CPK. CP/CPK is for capability analysis, and then I'll just take you to another 20 minutes is there, right? Don't save. Do this. Close it. Now. Right. See, are you able to see this?
Yes, sir.
This also I'm going to share it with you. This template will be given to you. Please note, defects or defectives, you have to select here. First, we'll select defectives. Defective means how many of them are rejected. That is what it means. So I have taken 500 samples. Opportunity for error is only 1. Either you reject it or accept it. That's all. Therefore, opportunity for error is always 1 for defectives. Therefore, it is not giving an opportunity for you to feed in any value. If it is defects, this will open up for you to feed in data. Now, suppose in 500 samples, I make it as 3 defectives. Then it is giving you short-term sigma level and long-term sigma level is given. DPMO is known. Total opportunity for error is 500 because 500 into 1 is 500. Defects is 3. 3 by 500 is 0.006. Multiplied by 1 million, you get 6,000. And short-term sigma level and long-term sigma level are opportunities are obtained from this. Now, defectives are considered here. Sigma level needs improvement. How much? Up to 6, right? If you get 6 sigma level, then you are best. Please note here, this is defects. This is called ZST. This is called ZLT. That means defects will increase over a longer period. That is why ZLT is low. ZLT is 1.5 less than ZST. So depending upon the green level line, the defects are diminished or increased where it is. So it should go to the right hand side end, right? Suppose I make it as 1 million. I have made 1 million, right? Now tell me what should be the defects for 6 sigma process?
3 to 4.
That's all. 3.4. So 6.03 has come, right? So 3.4, I'll put 3.4. 6. Clear? Understood? Okay, sir?
Yes, sir.
This is how you are going to. Now for defects, you select the defects, and then here opportunity for error, I can make it as 5, and then whatever 500, and then it will give you like this. So if I make opportunity, this is 2 lakhs, and then see it becomes 6, right? So 2 lakhs sample, opportunity for error is 5. Therefore, 2 into 5 is 1 million opportunity for error. Only 3.4 errors or defects are there. So 3.4 out of 1 million is called 6 sigma process. This is how you are going to use this. You can feed in any value here, select defects or defectives, and find out the performance short term. This question will come in your question paper. You can use this template freely on your lifetime also. Okay? I'll stop sharing. Understood? Clear?
Yes, sir. Yes, sir.
Now,
Yes, sir.
I'll just share it immediately after my finishing the teaching of CP and CPK. Right? CP and CPK, there are 2 ratios which you should know. How it is calculated, I don't have the PPT because I did not have time to select that PPT. But anyway, the PPT that I have at present, with that I will teach you. You will be able to understand that. Oh God, oh God, oh God, oh God, oh God. Is it CP-CPK calculation is there? Yes. See, this is how, please note, do you see the red lines?
So kindly share the screen, sir.
I did not share, huh?
Share avala, screen share.
Now?
Yes, sir.
Yes, sir.
Yes, sir.
I don't know how to adjust this. Yes. Yes. See here, these 2 red lines are there, no? Are you able to see this?
Yes, sir.
See my this plus symbol. And what are they?
Upper scale limit, lower scale limit, sir.
Given by whom?
Customer.
That's all. And that is in the numerator. That is given in the numerator. And what is this green area?
Accepted.
That is your process.
Okay.
That is your process.
Process.
What are the process limits? 6 sigma limits are there. Yes or no?
Yes, sir.
Yes, sir.
So what
Sir,
is the
yes, sir.
process giving? What is your requirement? Now this is in the denominator. And the numerator by denominator is called CP. Right? Understood? Here,
Yes, sir.
here CP is different. Yes or no? Is this
Yes,
a
sir,
good
yes, sir.
performance? This one, right hand side. Right hand side is not a good performance. Here it is a good performance. Yes or no?
Yes, sir.
Right?
Yes, sir. Yes,
How
sir.
to calculate the CP and CPK? CPK means, suppose this green area, I'm sorry, I'm not able to do this thing. Otherwise, I'll show it in the PPT. This green area, if it is shifted towards the right and close to the red line, is it a good process?
No, sir.
No, sir.
Yeah, even though this CP is very good, this process is not very good. That is given by this CPK. What is this CPK? CPK is the difference between the
Process
specification
capability.
limit and the mean of the process. And this is one. See here, the numerator has decreased. Denominator is 3 sigma, right? 6 sigma. Therefore, what happens? This becomes lower. CP and CPK should be same. CP and CPK should be same. Note, CP and CPK should be same. And CP should be 1.67. Right? Number one, CP should be 1.67. That means you can accommodate 1.67 times this inside this. You can accommodate this 1.67 times inside this. Right? That is what CP is 1.67. And this and CPK should be same for a good performance. Right? So now what you will have to do is you will have to put the values here. In this gray area, you can put the values here. Now give me a problem where you specify the limits as a customer and as a producer, you specify your process mean and deviation, and then it will calculate what is the ZLT and ZST and what should be done here. What should be done here? Please note, process variation is not all right. If it is not 1.67, if it is not 1.67, if it is less than 1.67, what you should do? We should reduce the variation. Clear?
Yes, sir.
If the CP is low, you will have to reduce the variation. Right? And then if CP is not equal to CPK, then move the target. CP is not equal to CPK, move the target. Like this is what I have to do. This green line, I have to move to the center. This green line, move to the center. Please, this green area, if it is moving towards the right or left, CP will not be equal to CPK. And CPK will be always lower than CP. And CPK should be increased to CP. Clear? Now give me a problem, sir. Tell me what is the LSL and USL.
LSL lower scale limit, USL upper scale limit.
Value. Huh? Give me one value, numerical value.
50.
50. So
Yes,
what
sir.
is the upper limit you want?
50.2.
55. Okay,
50.
what is the meaning of your process?
Mean 52.5.
52.5 is the mean. And what is the deviation?
Deviation.
What is the deviation?
2.5.
1.5.
2.5.
See here, process variation is not all right. Reduce process variation, right? So please note here, CP and CPK are same, but still CP is not good. Therefore, reduce the process variation. What you should do? Sigma should be decreased. Do whatever you can so that setting is properly adjusted and reduce the variation. Now reduce the variation, standard deviation. Reduce it.
2.5.
Huh?
1.
Huh?
Deviation 1.
1. Here I'll put it as 1.0. See here, still reduce the process variation. Right? Now still reduce the process variation because ZST is only 3.74. So what you should do? I will still reduce it to 0.2. Now it is good. I'll reduce it to 0.4.
CP, CPK greater than 1.67.
Right? So up to 0.6 you can go. 0.55. Please note, so your process should be like this. Then only for the customer requirement, your process is well within the range and giving you a 6 Sigma process. Is it clear?
Yes, sir.
Understood? Now,
Yes,
there
sir.
are two things. One is CP and CPK. CP should be what value? 1.67. Right? And it should be 1.8 or something for a very critical issue, I think. Very critical things. So 1.67, you can take it for granted.
So
And
greater
then
than 1.6 is correct, sir.
Huh?
Greater than 1.6 is okay, sir. It is a 4 sigma.
Okay, 2 is very good.
Yeah, sir.
3 is very good. 12 is very, very, very good.
Yeah.
Understood? But another
Okay.
CP and CPK should be same.
Okay.
Because otherwise it is not towards the target. Right? Okay.
Okay.
And if you have CP very high, say 3 or something, even CPK is low, it is okay. Probably it will be well within your customer requirement.
Okay.
Right? If it is 1.67, then you will have a problem there. Right? Higher the CP, CPK is equal to CP. Very good. Right? Now I will give you another these things. I will make it as 200. and I'll make it as 100. I'll make it as 160.
150.
No, 160. I'm just making it as 160. My
Okay.
process, no, my operator is full, yeah. He does not know how to set it. So 160, and he's put it as, and then 2.5. 15. See here, I am having 15. Process variation is not all right. Reduce the variation and move the process mean towards the target. Both answers are there. So they will ask you, what should I do? CP is so much, CPK is so much. You should say, reduce the variation and move the mean towards the target. These are the two result decisions you have to make based on CP and CPK. Understood?
Okay, sir.
Clear?
Yes, sir. Clear.
Now with this template also I'm going to share it with you. You can use it and think. And then I will take you to a PPT and then take you more class. Now I'll have to stop sharing. Yeah, how do I stop sharing? Please. Where is W web?
RK sir,
Yes, ma'am.
12 o'clock.
Yes.
12 o'clock Ravi will join.
I finished. Sir, you want the template or not?
Yeah, please post it in the chat window now. The
I don't know. Where was it? Yeah. Yeah.
Okay, so baseline performance.
Okay.
CPK. See, one of you please download the file and you can share it in the WhatsApp group.
And Jen's experiment also you want.
Yeah.
Yes. All the best. Thank you.
So all of you, do you understand CPK?
Yes, sir.
So which one you will look at first, CP or CPK? In order to
CP.
understand, tell me CP or CPK?
CP, sir.
Okay. So if the CP is, let us say CP is less, CP is only 0.5. Now what does it mean?
Process not capable.
Process
Not capable.
not capable. Very good. And CPK, then what is the purpose of CPK?
Sir, once again, sir, let me interrupt here. Please note, Prashant Kumar, in all these cases, whatever I tell you, very, very important. There are two things only we do. What are the two decisions? Reduce the variation, move the target. That's all.
Move the
Don't
mean.
bother about any other decision.
Oh,
Right?
move the mean.
Capable, not
target.
capable, increase the capability, and all these things, don't bother. Whatever be the problem situation, you have to answer only two ways. One is reduce the variation and move the target.
Not target, mean. Move the mean.
Move the mean.
Yeah, target is fixed by the customer. Move the mean. So now answer my question.
Now?
Sir?
Yes, sir.
Should I go there now?
No, your session there is 12:30 only. 12:30 in the black belt. Now Ravi is coming. Ravi has to join. So let me ask you questions with all the participants. So CPK. So suppose if CPK is 1.8, that is more than 1.67. What does it mean? Come on. CPK is more than 1.67. What does it mean? Process is capable or not capable?
Process is capable.
Capable. All of you please understand, CPK will always be more than CP. CPK will always be more than CP and in certain cases only CPK can approach CP, right? So if your CPK is more than 1.67, you can also understand your CP also more than 1.67. So to understand about the capability of the process, I want you to look at the CPK first. I want you to look at the CPK first. If CPK is okay, acceptable, more than 1.67, which means variation also under control, which means process average also under control. So process average under control means process average is close to the target, process variation also very minimum. So you are running an excellent process. Suppose if CP is more than 1.67, but CPK is, let us say, 0.8. Now what is your understanding? CP is more than 1.67, but CPK is only 0.8. What is your understanding now?
Process variation is different.
Variation
Is different.
No. See, when one of the metric is below 1.67, then process is considered not capable, right? It's considered not capable. And now why it is not capable? Either the average could have deviated or variation could have increased. To check the variation, you should look at CP. So why we require CP? To check the variation. Whether the variation is more or less, we come to know only by looking at CP. Then CPK will help us to understand whether the center is shifted or not. Right? If the center is shifted, CPK will go down. See, it will not affect the CP. Please understand. It will not affect the CP. CP will always, the same, will remain in the same value irrespective of the position of the center. So what you need to understand is CP measures only variation. If CP is good, variation is less. But wherever is the center, that CP cannot capture. CP has got a limitation. That is overcome by CPK. CPK will tell you whether the center is deviated or not. Clear, all of you?
Yes, sir.
And the requirement is 1.67. Requirement is 1.67. For non-critical process, 1.33 also okay. You remember, yes, the second day I taught you 3 sigma process. What is 3 sigma process? It is just capable. Just capable. Control, just capable means control limit, overlap on the specification limit. Control limits are overlapping with the specification limit. See, all the students here, please understand, just by participating in the program, nothing is going to happen. You must master, you must try to master. You must read 2 times, 3 times. That is the reason why we have given you recordings. How many of you have gone through the recording at least twice? At least important topics. Almost all the topics are important. Whatever we are discussing are important. If any of this question appear in the interview, if you answer correctly, the same moment they will issue the offer letter. If the company is talking about CPCPK and you are very comfortable with that, company will definitely hire you. How many of you understand the point? Will it happen or not?
Yes, sir.
Why? Because these tools and techniques are used widely in companies, and the professionals there, they find it difficult to take decision using the metrics. But when you demonstrate a lot of confidence in such tools, definitely they will prefer to work with you. Your interview will lead to a positive decision the same moment. If you see, people don't even ask you such questions because they general thinking is they think you do not know anything about all these things. But if you say you are an expert in Six Sigma, green belt, in the interview, then only they will talk to you. Okay, you are saying you are a green belt. Do you know CPCPK? Yes, sir, I know. CP talks about variation. CPK talks not only about variation, but also about the process center. If variation also under control, process center also under control, the process will certainly give good result. It is something like you coming to college regularly. You coming to college regularly and attending the classes very effectively. If you do both of these things, definitely you will perform well. If you are not coming to the college regularly, your problem is CPK. You have not understood the purpose. If the purpose is understood, process will automatically perform around the target. Isn't it? Process will perform around the target. Now only problem is plus or minus, some variation. That plus or minus you can control by controlling the CP. Right? But controlling the variation will produce the result only if the center is close to the target. So we need CPK and CP value of 1.67 for critical process. But for non-critical process, we need at least 1.33. And second day, we spoke about 3 sigma process, a just capable process. Just capable process means control limit will overlap with the specification limit. If control limit is overlapping with the specification limit, CP will become 1. CP will become 1, CPK will also become 1. When CP, CPK are same, you can understand process is centered properly. Only when process is centered properly, you will see CP and CPK getting the same value. When CP and CPK are having different value, you can immediately understand the process is deviated. You understand?
Yes, sir.
So CP equal to 1 means just capable, or CPK equal to 1 means just capable, but less than 1 means not capable. But industry requirement is 1.33 for non-critical and 1.67 for critical processes.